Hi, hello everyone. Thank you everyone for coming. So this is the very first hybrid meetup that we are doing. So I actually thank you all for your time for joining us here and the online audience as well who are joining us from YouTube. So hi, I'm Nitesh, and this is the very first hybrid meetup that we are doing. We actually have been doing offline meetups in the post-COVID time, in the pre-COVID time, and then we actually started with the online meetups in the post-COVID time, and we have actually also started with like the offline meetups recently as well. So we are actually trying to fuse them both and see what happens, and try to experiment around it and see like if it works out for the best. Yep. So just like this Flutter meetup, we actually have a lot of other meetups as well, like the React Native, the Web3 and design meetups. They're like new. We have recently started with that, and I think we actually have Angular meetups as well, and we have also have like groups for all of those meetups. And like if you want to tweet regarding any of these meetups, then you can actually use this hashtag, the Flutter BLR hashtag, and tweet about it. And also like I would request you all to like please put your phones on silent because that can actually disturb the speakers. So yeah, please do that. Okay, thank you. Yes, so I think we'll start with a keynote. So this is me. I'm Nitesh. I work here at GeekyAnts as a software engineer. I am actually a Flutter developer, so I'll be very happy to sit there and like listen to all the talks. So I'm just waiting to do that. Yeah. So we here at GeekyAnts basically love to experiment. We actually pick up on any tech that's new, anything that really excites us, and that is something how we actually met our love with Flutter. So we have actually experimented with Flutter from the very beginning of when it was launched, and that actually gave us the opportunity to contribute to the official Flutter documentation. So we have basically written like a part of the official Flutter documentation. And apart from that, like we also have a lot of other open source projects regarding Flutter, which include like the Flutter starter that you see over there. So it is something like whenever we start with a Flutter project, we need few aspects of it that will be there. So Flutter starter can actually help you with that. You can go ahead and try that. Then there's Flutter Flick Video Player, and then we have external app launcher as well. So these are like packages that are there on PubDev. If you want to use it, you can. And then we also have the Flutter Marketplace, where like we have a lot of pre-made Flutter projects, and we are actually trying to fuse Web3 along with Flutter, and we try to like experiment and document all of it and write articles around it. So if you are excited and you want to read about it, then you can actually visit our website, which is techblog.geekyants.com, and you can actually read it from there. Yeah. So let's start with the line of speakers that we have today. So first of all, we actually have Hasnain. He's over here. So he'll be talking about how we can build NFT store using Flutter. And then we have Samir. He's also present with us here offline. So he'll be talking about how we can use GraphQL with our Flutter apps. And then we actually have the online meetup, uh, the online aspect of our today's this one, where we'll be joined by Aditya. He'll be talking about Material 3 in Flutter, and then we have Vikas. He'll talk about like the performance and optimizations in Flutter, and then like of course the code of conduct. So do not use any hate speech. So this is mainly like for the online audience that are joined us with YouTube. Try to keep it light, and yeah, be respectful. Also, like regarding the questions aspect, don't spam questions in the chat. Just post it there. We'll get back to you. And yeah, for all of us who are present over here, just go ahead, network, and yeah, try to talk to each other. Yep, that's all. So we basically have like the first speaker, who is Hasnain. He works at Toshiba Software as a software engineer. He is also a YouTuber, and he actually posts videos as well. So he'll be talking about building NFT using Flutter, right, Hasnain? Yeah. So yeah.
Cool. So, getting this stage after 2 long back years, I've done many talks and meetups over here. So, we'll be thankful to the GeekyAnts team to organize. I'm not sure. We'll be thankful for GeekyAnts team to organize this, high meetup. Fine. Okay. So this is experimenting right now with the hybrid. We should even take care for the online that we should be in frame. It's fine. I guess okay. I'll just remove my. No. Okay. This makes me nervous more. Well, I'll start once again. So I have been doing Flutter meetups as well as talks with the different universities. I can see a couple of known faces over here, which I have been like seeing them after a long time. Uh, Coming to me, my name is Hasnan, and I work for Toshiba Softwares India as a software engineer. Uh, I am a blockchain enthusiast, experimenting few things as well as build a product NFT store in the blockchain, and which is in the beta and it's live right now. Also a video creator, sharing my knowledge, recording things, what I'm doing, experimenting, and then uploading on the YouTube. Uh, Currently, interacting with the startups and discussing ideas and converting them into the products. Flutter mentor, helping universities, students to learn Flutter and getting started with the Flutters. So have done more than 6 work with the different universities. Also speakers at different conferences and meetups. Coming to the today's topic, I'm going to share what I have done doing experimenting the blockchain things and building an NFT store. Here is the contents what we will be what I will be discussing and what will you will be receiving from my end. So first we'll have a short introduction about what is Web3. We'll talk about smart contracts. We'll talk about what are the basic steps to mint your first NFT. Of course, if we talk about NFT, we need to learn about ERC 721 standards. I will be also talking about the dev packages which is required to build NFT store in the Flutter. We'll be talking about Web3 client, Wallet Connect, and then we'll see a small app. If time permits, I'll connect my phone and show you live, or else I have the screenshot to share. Later on, I will be sharing the same GitHub repo so that you can, take a look on the source code as well. And then I will have closing notes, and at the end, I'll be taking the questions. Well, let's talk about what is Web3. Most of them right now using Web2, and that is, uh, being controlled by the people or one single organization. But that's not the case in the Web3. Web3 is, decentralized, and no one have a control over it. I would say the community have a control. So not a single organization is going to control the complete application which is built in Web3. It is since no one has a control, so everyone has rights to put their own views as well as building their own things. So it is more democratic. Uh, it's an anonymous single sign-on, because when you want to connect Web3 with your web application, it's obvious that you need to connect your wallet, right? So wallet is you are having a single address, and that is anonymous. No one knows this address belongs to whom. Uh, Individual There is no individual ownership. I mean, there is an individual ownership and tokenization. So let's say if a person A comes in and wants to have their own tokenization, they can go ahead and they can launch their own tokens on the blockchain and different and yeah, it's a self-governing. So you don't need to follow some rules, or there is no rules and regulations. So it's a self-governing. You can take care of your own product, and you can do whatever you want with your product. Let's talk about NFT and how it works. Like, we need to understand what is minting and what are the steps involved to mint your NFT. So let's first take a look the complete architecture of how smart contract works and what are the things happening. So let's say we are the users and we are having a devices. So what do we do is we interact with the smart contracts. I will talk about what is smart contract in the next slide, and then the smart contracts interact with the EVM wherever a bytecode or the code works, and then it stores the data and reads the data from the different blocks available on the blockchains, right? So this is the simple architecture how exactly the blockchain or the Web3 works. So very first thing is uh, what you need to do is, let's say this is my app, right? This is my minting form. So this app, what does it do is we log in through our Instagram, right? And it converts your Instagram post to an NFT. So I'm picking this image from my own logged in account from the Instagram, and then I have a minting form. So very first thing what I need to do is I need to convert this information and need to put on the blockchain, right? Because you need to have those things what you are putting into your screen needs to be there on the blockchain, so that every single person will see what is happening or what exactly NFT is having, right? So you can see I have a media URL, name, description, Insta users, and the price, and of course the metadata of the image, whatever. So what we need to do is we create a JSON file, we upload it to the IPFS so that every single person knows what content of this NFT is, right? Just having an image doesn't give more information, so we need to combine image as well as the metadata, or the what we would say is the information about the NFT. So every NFT holds an information in the JSON format. It goes to the IPFS, and IPFS returns us as a hash. So you can see the flow is like I convert my mint form to a JSON file. JSON files goes to the IPFS, and IPFS returns me one hash. So this hash, whenever you use this hash, you're going to get the contents of the file. Now, in this smart contract, this is my smart contract method called create NFT. In this smart contract, what it does is I need to use this token URI. Whatever the hash written from the IPFS will directly go to this set token URI. So now the set token URI is taking the ID of your NFT, the token ID, and combining your token URI. So this is the same hash what we received in the previous slide. So I am giving the IPFS complete domain, combining with an HTTP link, and then using my token ID with the token URI. So what does this do is like just combining your token ID with the URI. So whenever if someone query on blockchain that this is a token ID, it's going to return me the content of the NFT. So I'm just gonna give you a quick look on what exactly I'm talking. So let's say I'm going to query the token URI with an ID of 1. So I'm just providing a token ID over here, and I'm just going to query. So you can see I have a one link coming up, and if I open this, I'm going to have a content of the complete NFT. So this was the NFT which was minted just few hours back, and it holds the URL of Instagram image right over here, and the name and the Insta who has minted, right, and the price of the NFT. This is pretty much about token URI. So you might be knowing how you're going to combine your token ID and your token URI. Now, let's take a look what's happening with our smart contract. So when we write a backend, we might be using Python or Node or whatever. So when it comes to a blockchain backend, we will be using smart contracts, which runs on the Ethereum blockchain. There are multiple blockchains. This smart contract is running right now on the Ring-B testnet. So this smart contract shows me a piece of code which is inheriting the ERC 721 storage. I will talk about what is ERC 721 in the next slide. So I have a contract called MyNFT, right? And I am using these counters to get a increment of an ID every single time when I mint the NFT. It has a constructor which is going to hold the name and the symbol of my NFT. So the name is Insta NFT, and the symbol is INFT. So just to make sure on the blockchain, so this is the Ring2B blockchain. So if I go to the transaction which was minted, which was created very first time when the contract was deployed, and this is the contract. So you can see the token tracker shows me the same inputs which I provided over here. So it's Insta NFT and INFT is the symbol name. So this is how we create or create our first NFT token. So you can see the event over here, NFT minted. Right now, whenever the NFT is created, this event is going to mint. Whenever this event is going to get emitted. Now every front end which is connected to the blockchain is going to take a look on this particular event. So whenever the transaction is done, this event get triggered, and we get to know, okay, our transaction is confirmed, and this is the outputs coming from our smart contract. So you can see it's a simple 5 to 6 line of code which takes the new ID and then mint the NFT. The player is nothing but the person who is minting the NFT. And then we are setting the token URI. So the new ID will be linked with our token URI. And then we increment the token, and then we emit the token. And we emit the event, returning the new ID. And then we return the new ID so that our front end can know what is the latest ID what we are getting from the smart contract. So this was the smart contract. It is pretty simple, just 5 to 6 line of code. And if you deploy that smart contract, and you are on the blockchain having your own NFT token live. Right now, we need to understand about ERC 721 standards. So any smart contract which is having who wants to prove that this smart contract is an NFT, and NFT smart contract which is capable of minting an NFT, then those smart contracts needs to follow all these functions. If one function is missing, that smart contract is not qualified to be an ERC 721 NFT smart contract. So these are the functions or the standards we need to follow if we want to have our smart contract to be called as ERC 721 minting NFT contract. Now that was all about blockchain. Now let's focus on towards the Flutter side. How can we interact with blockchain using Flutter application? So these are the 3 main packages which you need to use to interact with the blockchain. These are the basics, I would say. Now the other could be added depending on the requirements. The one is the URL launcher. We know it opens app as well as browsers. The other one is the wallet connect Dart. What this package is having a capabilities, every mobile is going to have a wallet, maybe a MetaMask or a Trust wallet. So whenever we want to interact with the blockchain or with the smart contract, we need a wallet, and our wallet will be signing a message and then connecting with the sending the transaction to the blockchain. So wallet connect works as a connection between our blockchain. Our Flutter app will be connected with the different wallets. So wallet connect supports multiple apps. We can use any of them. And Web3 Dart is used to establish the connection with the Ethereum nodes running over the different servers. So we need to use infra API, and then we need to use that RPC URL. I will be showing what is RPC URL, so that you can directly connect your Web3 as a client with the blockchain node. Coming to the Web3 client, so you can see I am using Web3 client and passing 2 parameters over here. So I have a factory method which is called as Ethereum transaction tester, and the Web3 client is coming from the Web3 Dart library. The first parameter, which is just a kind of URL. So this URL is being used as an RPC URL. It's like when we use a REST API call, we create our own routes. In the same way, this is a specific route which will help us to connect with the Ethereum blockchain node. And then I'm passing the client object. The client is nothing but we are saying Web3 client that this client is coming from our HTTP package, so that whenever we establish the connection, it acts as a client and the Ethereum node. The other is the wallet connect via Meta. So now let's say if you want to connect your wallet, I'm using wallet connect class. So what happened is I need to use this bridge, right? So this bridge is smart enough to understand that where exactly things are connected. So what happens is whenever if I can show the logs in my app, sorry, I don't have a logs over here, but yeah, what happen is when you initialize your connectors, what it going to do is it is going to return one, or I would say it is going to establish a WebSocket connection. So WebSocket connection is going to established between between these bridge, right? And any action happens, the event occurs, and that can be monitored anywhere where you are connected. So this wallet connect help us to connect with the applications or the wallets which are capable to establish connection with the wallet connect. So these are the basic parameters you need to pass. So I would more talk about the client meta. So client meta is nothing but it's all about your application, what exactly it is. So you can have your own domain over here, you can have your own application name over here, and you can have your own application icon over here. So as soon as you trigger this, what it will do is it is going to open um, a MetaMask wallet or the wallet which you're trying to open. But let's see what could be the other thing you need to do. So you have a wallet connector object in your hand which holds all the information that, okay, this is my client information and this is what I'm going to have as a connector. Now what you do is you need to use the connector, and then you need to call a create session method. This will directly open your app to which asks to connect your wallet with our Flutter app. So you can see over here I'm passing chain ID. Chain ID is nothing but the Ringby test network. So this holds every network has their own ID. So I'm passing chain ID over here, and I'm having an on display URI callback. What it does is, as I mentioned in the previous slide, this is going to return me a kind of one URL. So I'm going to use that URL over here, and I'm going to launch the application, whether it could be a Trust wallet or whether it could be a MetaMask wallet. As soon as launch URL string encountered or compiled, it going to open the MetaMask in your wallet, in your mobile app, and it is going to ask you whether you want to connect your wallet with your application or not. So as soon as you say yes, connect, you are successfully connected with the Flutter app. So your Flutter app is now capable of interacting with the blockchain. Now let's put everything together. So over here you can see I have a factory method which is Ethereum transaction tester. So first what I will do is I'll get the Ethereum, where that is nothing but the making RPC call to the blockchain node and having an Ethereum blockchain node into my Flutter code. And then I'm going to have a connector which is nothing but again saying your wallet connect that I am the client and these are the information, your application name, your description, your URL, your icon, and then I'm going to have a provider. Now, why we need provider is because when we connect our wallet, as a Flutter developer, you don't know what is the private key, right? So whenever you're going to send your transaction to the blockchain, you need to always assign a transaction using your private key. So we are just accessing the public key, and provider is capable enough, or the Ethereum wallet connect provider is capable enough to get the public key, get the private key and sign your transaction. So this complete method returns me three things: the connector, Ethereum, and provider. Now using these three things, I can connect to the blockchain and I can perform the transactions together. Now I have already gone through the code in the previous slide, but again over here, just to have a more focused on so I have a function called create NFT, which is going to return me u into 56, but nothing but an integer. So this is a smart contract code. This is not a Dart code. This is a smart contract code. Sorry, I forgot to mention. So what it does is it increments first, it get the current token ID, then mint the token ID and the address, the wallet which we connected in the previous slide. So player will be having the connected address with the wallet. Then we combine using a set token URI will be having that new ID and token URI. And then we increment, and then again we mint the we emit the event so that we can get to know what's happening with our transaction. Right, this is a pretty simple code from the smart contract. Now what we have to do is we need to make, okay, something is weird, I'm not sure, the code is not getting highlighted. Okay, so now what we need to do is we really need to tell our Flutter app that the blockchain function is going to look like this. So we need to tell our Flutter app that the blockchain function is going to have a signature of something like this, because see, our blockchain application doesn't know what exactly the function looks like, right? So whenever the blockchain code compiles, it returns an ABI, right? That's a smart contract ABI. It has a JSON format which tells us what is going to be an input and what is going to be output, what type of function it is, the function name. I'm not sure. I have highlighted the code, but okay, this is a pretty big ABI. But I could have shared you the. Okay, I guess here it is. No, I'm not sure. So smart contract ABI is nothing but the signature of a function which is on the blockchain, so that our application can understand, okay, this type of function it is. Now let's see how we are going to use that signature into our Flutter app. So as I mentioned, I have an ABI right now. So let's say this ABI is so big, right? The ABI is quite big. I'm not, oh, okay, I have, okay, here it is. Okay, I got it. So you can see the inputs are two things. The first one is the address, which is name as in player. And the second one is as token URI. And the name of the function is create NFT, which is going to give me an output of U into 56, which I previously mentioned. So here is the complete input token URI. Right. So now using this JSON format, I will be able to tell my Flutter app that these are the inputs and these are the output and this is the name of my function. Now I will be using, see, you can see the smart contract, the smart contract ABI is quite big, right? We cannot always go ahead and write the same template again and again. So the Web3 the package what we used previously is capable enough to, using build runner, we are capable enough to generate the piece of code which we don't have to write again and again. So what I'm doing over here is I'm just using the build runner and using my contract.abi.json as an input over here. So I'm going to run a command called flutter pub run. So it is going to detect the files which are ending with .abi.json, and it is going to create one Dart method or a Dart file, which is going to named as whatever we have named for the JSON file, right? So now the generated code looks something like this. So you can see we have a function name. So this function name, the build runner picks the name from here, right? And even the parameters are being picked from the same thing. So you can see the player and string URI, and the return methods also picked from the same part. So this is the piece of code which is being generated by the build runner. So we input the ABI and we get the complete template, so that we don't have to we don't have to write for each and every functions. Right. So this was the generation of code to interact with our blockchain. So now the blockchain code is right over here, right? And the same code has been in our Flutter as well. So now create NFT will be our Flutter app will be able to call create NFT function on the chain easily, because now we know what should be the input, what should be the output, and what it should do. So moving forward, this is our Flutter app minting NFT function. So we have a contract. Contract is not the file generated from our build runner, right? So what I do is I give a deployed address. So basically the deployed address is nothing but this address. So I put this as an input as an address, and our Ethereum, which which was which we used as a URL node connection with the node, and then the client. So Ethereum, this is going to interact as an work as a client. So the contract takes two things. The first one is the deployed address and the client. Now we need a credentials. I said that, right? We need a provider because we need a credentials. Credential is nothing but getting the private key. Without private key, we cannot sign the transactions. So now we need to sign our transaction and send it to the Flutter to the blockchain from the Flutter app. So I will get the credentials. As soon as I get the credentials, what I will do, I will ask my URL launcher to open a decentralized app which is installed on my mobile phone, whether it is going to be a MetaMask or a Truffle. Not Truffle, or a Trust wallet. So this is going to open a decentralized app browser, and what it's going to do is, okay, well, this over here I will explain why we need why I have mentioned google.com. Now this function, right, the create NFT accepts two things. The first one is the address, and the third thing is our token URI. So and the third thing, credential, is because in the previous over here, we can see it is asking for credentials because we need to sign our transaction whenever we call the write function. Write function is nothing but sending a transaction to the blockchain. Whenever we need to call a write function, it takes the credentials. Credential is nothing but the private key, our transaction, and the what type of function it is, and the params. So we have two params. We have a function called create NFT, and we have a credentials. Now, as soon as the create NFT get triggers, it is going to call or open MetaMask. So you can see as soon as I click mint NFT, it is going to open a MetaMask. So you can see at the bottom there is some Google search engine open. Now there was an issue with opening with the MetaMask in the app's iOS device. It doesn't open the MetaMask directly; it opens the App Store. So I just came over across the active thread on the MetaMask GitHub repository, and for now the hack is like that. You need to open a browser to open a MetaMask wallet directly. So you can see I have a form which opens or which asks to sign a transaction, create a transaction, confirm it, and send it to the browser to the blockchain. So you can see I have provided the information, and it is going to open a MetaMask wallet. As soon as I confirm, it is going to say me that your transaction is pending until and unless I get a confirmation. Now, how do you recognize whether your transaction is confirmed or not? So over here you can see I have a confirmed transaction from the blockchain, and it is going to return me a token ID. So now moving forward, how do we make sure that our transaction is going to get confirmed or not? So yeah, over here we have as I mentioned, we have an event in the smart contract, right? So this is the smart contract. What I do is I just create a stream subscription with the smart contract, and I just give the event over here. You can see the NFT mint event. So this complete function is coming from the same build runner code, right? So in the ABI, everything is there, right? Over here you can see this is this build runner code which was generated, and it is going to search for this event. As soon as these events get emitted, I'm going to get the return parameter from the smart contract. I get the event.new item ID. This gives me a new token ID, and then I just cancel the subscription. Now I can do whatever I want over here once this stream subscription is giving me a listen event, right? So on the callback of listen, I have all control over what I can do. Okay, so this was all about minting your first NFT and converting your building an NFT store into a Flutter. Now this was just about minting, but the NFTs are being the NFTs are just not just for minting. It is moreover on buying and having transaction on it. But we need to be more secured when you're going to write buying transactions on the NFT, right? We cannot store personal information into our NFT smart contract. We cannot, use. We have to always use a signature-based authentication as well as in the Flutter DApps. So this was all about closing nodes, that we need to always have a secured smart contract to do a transaction or a settlement transactions with the smart contract. I'm open up to take questions. While I take questions, I'm going to have a short live minting which I have built, which converts the Instagram post to. So I'll be just showcasing builds. If you have any questions related to blockchain or any questions related to a decentralized app, I am open up to share my insights as well as. So do we have any questions? Okay, so let's wait for our application to build. I guess I am running out of time. If just 2 minutes more, I guess. Yeah, it's installing. Come on.
I have a question.
Yeah, sure.
That's a nice presentation. I would like to know, like, do you guys use any Node.js scripts for installing this blockchain stuff?
See, it depends. If you are writing your, backend in a node, then you, of course, you need to have an npm package to interact with the blockchain. But right now, okay, just 2 seconds. I'll continue. I'll just showcase the app. So you can see I am just trying to log in into my Instagram using our Flutter app. I'll just give allow, and I have a minting form available now. Since I have an access token from the Instagram, I'll be able to get the post from the Instagram. I have the two posts available. Before I fill my form, I'm going to connect. So this is going to open a MetaMask. It's visible, right? Yeah. So now you can see it is asking me to connect my wallet. I'll say yes, connect my wallet, and I'll be back to my app. Now you can see I can mint the NFT. Before it was connect wallet. Now I have kept I have an Ethereum node connected to the wallet. So now I can mint my NFT. So I'll just say minting from stage. This is test minting, and I'll just give some price. Let's say 0.99 ETH. Right now I will mint my NFT. So you can see the transaction is a pending state. I need to sign a transaction over here. Come on. Yeah. Now I need to sign my transaction over here. This will ask me that I'm going to pay this much gas fee, and this is what it is going to cost for now. I'm going to say confirm. As soon as the transaction is being sent, the transaction is still pending. As soon as the event gets emitted on the blockchain, once the transaction is done, so you can see the transaction was done, and I'm able to get the token ID. Now I can clearly check the transaction, complete transaction over here. So the transaction is still indexing. I would like to get more focused over here. So done. So now you can see I have a token ID of 2, and if I will go to my contract, and if I will read my contract, I'll query, I want a token URI or the information which was being, I will pass to, got the URL, I will use this URL, and I will open it. So you can see the same information what we passed is been attached with our NFT. So this is the media URL, the same image which was being used right over here, right? And all the same information which was being used in the NFT form. So right, this is how we mint our NFT. This is not a limit. This is just limited part. We can have more transactions over the NFT. Right. So coming to your questions, it depends on what what client you are using. If you're using backend as a node, then of course you need to have a npm package to connect with your blockchain nodes. So yeah, that's all from my side, and I'm going to make this code open source on the GitHub so that You can get it. I will be, maybe the plan is like sharing the link on the YouTube video, commenting on the YouTube video, or I'll be sharing the link with the admin. Yeah, thank you. And sure.
For teaching us about how we can actually go ahead and some NFTs. So yeah, everyone, go ahead, mint some NFTs, sell some NFTs, become the next Logan Paul, Gary Vee, whatever you want. Yeah, thank you. So we actually have Samir as our next speaker.
But then we can have an advantage of I would say, responsibility and putting some extra effort to do that we can have an app itself where they will have maybe base meetings of that exactly.
Okay. Hello, everyone. Hello. Like, yeah. So we have Samir over there. He'll be the next speaker for the day. He'll be talking about GraphQL powered Flutter apps. He has joined us from front row. So yeah, Samir, it is yours.
So hello everyone. I hope I'm audible. Uh, so yeah, I'll be talking about GraphQL today. Uh, I hope you have some clue about what GraphQL might be, but I'll be going over it as well. So a bit about me. I am from Bangalore, and I currently work as a software engineer at Frontro. Frontro is a tech startup, and I was previously involved in a lot of fellowship and community programs. And I've been interested in GraphQL since over 2 years now, and I've been closely following the technology, attending meetups. And the last GraphQL summit was in Bangalore in Leela Palace. So that is the last time the guy attended a GraphQL event. Since then, I think GraphQL has grown a lot, the ecosystem as well as how GraphQL is used. Coming to before I explain GraphQL, let's take a look at the problem with REST APIs. So if you're all aware, if you have done any kind of front-end development or back-end development, you know about REST APIs, and there are certain limitations that come along with it. The biggest ones are like multiple round trip times. So sometimes you have to make multiple API calls to just get some data because that data might be dependent based on the relationship of the previous data, and then overfetching and underfetching. So I think this is one of the most common things that happens in REST APIs. Because suppose you're on a profile screen, if you're on a post screen in Instagram and you want to see the profile data, you have to sometimes you have to fetch the entire profile data in that same API that which you might not even use on that screen. But again, to go to the next screen, you'll have to again fetch that data, and it sort of becomes redundant at some point, where you are fetching unrelated data that you will not use. And I think the biggest pain point is also that there are too many endpoints. If you've ever worked on a very large scale enterprise application, you know that there are more than 100 endpoints or even 1,000 endpoints sometimes. So it might get a bit tricky. The main mistake I make usually is like hitting the wrong endpoint every time, and then I take an hour to debug and just to see that the endpoint is wrong. So this is one of the most annoying things that I see. And also one more thing is that it's schemaless, meaning you can send anything in a REST API. It doesn't have to be of a specific structure, or you don't have to specify any kind of relationships or types with it. So REST APIs allow you to send anything and everything, because of which you might sometimes not be aware. The front-end developer might not be aware what changed in the backend, right? The backend developer can change anything, and the contract might fail because they're not the same, and there is no contract specifying to the backend developer that it has to be the same way. So GraphQL sort of helps in tackling all these problems. So to get a brief idea of when GraphQL started, so GraphQL is actually a specification. It's not a framework or a language or anything else. It's just a specification which tells how differently we can send data in through the internet to applications. And it was actually developed by Facebook. So I think logically, Facebook is a very big application, and there was so much data going back and forth in their mobile apps, and they decided that they wanted to invent something that could make this process efficient, and that's why they built GraphQL. So I'll be going over the basics of GraphQL so that you get a basic understanding of. So in REST APIs, like I told, it's basically you usually send JSON objects, right? And I think that is the most common form, although you can send other things like XML or even text, plain text. But what happens in JSON is that I think there are very few types. Because it's a JSON object, I think it can be only a string or an integer or double, these kind of things. But GraphQL allows you to customize uh, multiple different kinds of types. So as you can see, it has a specific ID type, which is very different from an integer or a string, and it also specifies int, float, boolean, custom scalars like dates, enumeration, this interfaces, and all these different things that you would find in a very high level programming language. So this sort of helps in creating that relationship between the backend and front end, so that both of them are in sync and they do not like fail at any point. So yeah, so going over the things of how GraphQL works. So in REST, I think the most common ways of interacting are the 5 HTTP methods: post, get, delete, update. But there are no such things in GraphQL. In GraphQL, there is only one method, which is post. You always send a post request. You never send any other method. And within that post request, you specify a type of schema which tells GraphQL server what you want. And the good thing about GraphQL is always the front end decides what it wants and never the back end. The back end is always prepared to send anything the front end wants, and only the front end will ask whatever it wants. So the front end developer here decides that what data he wants, rather than REST, which I think usually the back end developer decides the schema. So the first highlight is the type system. So like I told that GraphQL has a very strong type system. This helps in forming relationships quite easily. And the next thing is a concept called queries. So queries are just like GET requests. Queries are used to fetch data from the server, and the good thing is that you can specify what kind of data you want. Uh, so in a query, which I'll show in an example soon. So in a query that you can specify the fields that which you want, and GraphQL will return that. And then there's mutation. Mutation is similar to post request, where you're actually telling the GraphQL server that you want to mutate some data on the database, and that's when you send your parameters. And the cool thing is that in every mutation, you also get back the same data that you modified, or you can ask for whatever data you want within the same request. And then there's also subscriptions, which is the coolest part I think about GraphQL, is that you don't need to maintain a separate WebSocket server. GraphQL natively provides subscriptions which are like a connection, a real-time connection between the backend and frontend. So you don't need to create a new WebSocket server and then maintain that. And all of these work like they all work together very functionally. Uh, Yeah, and I'll just go over a few examples of how queries look and how different comparison with REST APIs. So you can see that in REST APIs, this is how your APIs would be like. First, there will be user to get all users. Then to get the post of that user, you would have to specify the user ID and then post. And to get that particular post, you would have to again get use a different endpoint. But in queries, in GraphQL queries, it's this simple. You just specify that you want users and their posts and what all you want in their posts. So it gives out the entire list and even nested objects within it. So instead of using three different endpoints, you can accomplish it in one single query. And then same with mutations. So even to if you want to mutate some different data on the backend, you would have to send different API calls. But again, in mutations, you can just do it with one, and you can also get back the data easily. And then we have subscriptions. Uh, yeah. So like I said, in subscriptions you usually create a WebSocket server, but in GraphQL you just create. This is what you do. You just call a subscription and send this as to the GraphQL server, and it keeps listening to the subscription. And you can also ask what kind of data you want in that subscription. So when do we actually want to use GraphQL? Obviously, it's not the best. It's not a solution for every scenario, and most of the cases still REST is very prevalent. And I think the best use case of GraphQL is when you have a lot of different microservices running, and you usually have a central middleware which will combine all this data and send to your front end. And that is the best way to the best place to use GraphQL, because I think the biggest part of GraphQL is that it is very predictable for the front end. So having predictability between middleware and the front end is really important, so that no unknown data comes on the front end if the front end fails. So this is the best place to use GraphQL, where it is acting like a middleware between your client and your backend. So GraphQL is actually using GraphQL is very easy nowadays, because there are companies who are working to make GraphQL very instant. So I think some of these service examples are Hasura, which is from Bangalore, and they are very huge in this space. They're the ones who organize all the GraphQL meetups here. And there's also AWS AppSync. I think this also uses GraphQL APIs. And there's also AWS Amplify, which is an alternative to Firebase, and it provides its responses in GraphQL. So that was about GraphQL. So coming to how we can actually use it in Flutter, because I think that is the main focus of this meetup. So the GraphQL ecosystem in Flutter is quite big. There are multiple sets of packages which you can use according to your taste. And I think the GraphQL and Flutter GraphQL are the most popular ones. They have been there for a while now. But there have been new packages that have tried to sort of maximize productivity, minimize the amount of code you want to write, and all those things. And also the services that I mentioned also have their own packages to connect to their services. So I'll be showing one specific package which is called Ferry, because I found this really interesting, as it helps you write very less code, because it generates most of the files. So Ferry is a GraphQL package which helps you interact with the GraphQL server. So how this package does it is very interesting. So all you have to do is I'll show in the next example, where you have to just give it some input schema of telling it how your data will look, and Ferry will actually generate all the types for it, all the requests that you require, and all the classes that you require. And here you can see in the example that this grooms request is actually the request for a particular data type, uh, a particular data that might be expected from the backend. And again, the response object. So it creates all the request and response object with the parameters built in. So you can just use them directly within your code. And it also has a the Flutter side. So it also has widgets where you can use to directly listen to operations or perform operations like this, which is called the operation widget, and you just give it that whatever the request was, which was fetch rooms, and it will directly render the widget. And yeah, since to use GraphQL in real time and to use subscriptions, you'll have to use a WebSocket connection on the Flutter side, so that it can listen to the incoming requests and stay connected to the server. So to demonstrate the power of GraphQL, I'll be sort of showing a very simple chat app. which I built. So let me just go to the, it's very small. Yeah. So to actually understand GraphQL, we have to know a little bit about how GraphQL works on a server. So I'll just quickly go through that code first. I have a very basic Node.js server here. If you know a bit about JavaScript or TypeScript, you'll be able to grasp very quickly. So all of this comes out of the box with something called the Apollo server. Apollo is a company who is building the GraphQL ecosystem in JavaScript, and they have all sorts of packages, tools, and anything you want to build GraphQL apps at scale. So they have this Apollo server which instantly creates a GraphQL server easily, and you just have to give it some inputs, and it will take care of the rest. So I've just instantiated a server here, and then the most important part of GraphQL is something called the schema. So the schema of a GraphQL server specifies what kinds of data you will be using to send to the client or to use it within the backend. And without this, a GraphQL server won't work. So this is what gives GraphQL the power it has of maintaining relationships and showing strong type system. So you can see here, first, since I'm building a chat app, I have two data entities. One is message, the other one is root. And I've also given what all fields it will have. So you can see there's something, this exclamation here. So this is called, this is to enforce the rule that a GraphQL server will never return this as null. So if you mention this, there is no way that the server can ever return this field as null. So I've just mentioned it to things that can never be null in this data entity. So something like ID can never be null. So that's why I mentioned it. And you can also mention generic objects and nested objects. You can see here I have users, and it gives a list of users. So user is a different data entity altogether, and you can nest objects like this. And then the next part is queries and mutations. So whatever queries that you're also going to send, you will have to mention it in the schema, because that is how GraphQL will be able to predict what kind of operations you'll be performing. So here, relevant to this app, I have two queries here. One is messages, one is rooms. So rooms just gives out the number of chat rooms available, and messages gives all the messages in a particular room. So you can see that I have. That's why I'm taking an input of room ID and giving out a list of messages. And a mutation also, you can see relevant to this, there is a create message, which is the one I'll be using. So a message would require something like room ID, to which room it belongs, the content of the message, and the who created that message. Right? And then the next most important thing is something called resolvers. So GraphQL resolvers are what handle the logic of what data to send and how to send the data. You can see for every type of query or mutation I have a corresponding object here. In this resolvers object, I have something called query, and inside that I have a list of queries. So rooms and messages are one example here. I'm just storing this data locally in a file, and then I'm just returning that data structure to the server. And similarly, there's subscription as well. So whenever I create a message, I send a subscription. So let's check this out in action a bit. And the next big thing about GraphQL is the GraphQL playground that you get. So most of the servers come with this playground. Here I'm using the Apollo Explorer, and you can see that the biggest feature is that GraphQL is self-documented. Nobody needs to write extra code to document what each query or mutation means. I just have to write that code, and GraphQL recognizes what kind of data I have, what kind of queries I have, what kind of mutations I have, and what are the fields that come with it. So let me just quickly show an example query. So like I told, you can only request the data you want, and here I can only request ID if I want, and GraphQL will return it to me. I have rooms. I have two rooms currently with ID 1 and 2, and if I want more data, I can also ask it more, and it will subsequently return me more data as well. So this is how it really. I think this is a really cool feature. And then let me just send a message as well, or let me just show it with the app so that it will be helpful. So coming to the app, let me just quickly go through the app code as well. So to use the particular package I was talking about, you have to go to your project.yaml, and then a package called Ferry and Ferry Flutter. After that, you create a folder with whatever name you want, and here again the most important thing will be specifying the schema of that GraphQL type you have. So you just copy paste it from the server and put it in the Flutter app. So I'll put the entire schema of what I'll be using, and then we'll also have to specify what the queries. So whatever I showed here, this query will have to specify in the Flutter file so that we can tell query what exact data are we requesting, so it can generate the fields for that particular query or mutation. So you can see I've made a file called queries.graph here, and I've mentioned what kind of data requesting and what is the name of that query. And then the same with mutations. I've just created a mutation, and I'm telling it what data I'll be sending and what data I'll be requesting back. So after this, you just have to run the build runner package, which helps in generating files. And you can see all these files are generated. And if you go through them, you'll discover that query has generated all the necessary classes that you have to make a request. And if I go to client, and so this is where I instantiate the WebSocket link so that our Flutter app can connect to this server and keep listening to it. And then we also have yeah. So how I've executed this is I have a simple change notifier. If you're familiar with Flutter state management packages, so this just helps me separate the business logic from the UI. And what I'm doing is I'm doing very few basic things here. One, I'm just fetching the messages for a particular room. So whenever I go into a room, I just fetch all the history of those messages in this room, and then I'm also listening to the messages so that I can chat in real time with the server, and I can basically have a chat at that time, and also send message to send that message back to the server. So yeah, in the view again, this is the chat view. I'll just show the UI as well. Yeah, so view I have. Basically, you can listen. You can see that I'm using provider to sort of listen to those messages, and I'm rendering those messages on the screen using this map. And on the other rooms, I think I'm using the ferry provided widget, which is like I told, the operation widget, where you can directly fetch the rooms that you want, the request that you'll send, and it will execute it and render the widget accordingly. Just a minute. Okay, so let's actually, once the app starts, we can sort of have a real-time chat. So one of the clients will be this sandbox that I'm using. So this will be the other client, and my mobile app will be the second client. So this I can send messages from here as well and from my mobile app, and they will both receive the message since it's a real-time chat. So I can once I have a subscription and I start this whole message, you can see that the Explorer starts showing that the subscriptions are like listening. You can see it's listening to the server continuously, and whenever I just send it to, so if I send a message now, you can see that the messages also got reflected here, and if I go to the subscription server, they came here as well, right? So these are the two groups. Okay, you can see my phone screen. These are the two chat groups that I currently have. One is the meetup that is happening. So let me go into that, and currently it's empty. So in one of these plans, I'm listening. So whatever data I send here should technically come there, and you can see it came. Yeah, so you can see I sent hey, and it's from me. So it came. So I'll be chatting as GeekyAnts in the other client. So I have created a user for them. And I'm sure it's easier than I do. That's fine. Yeah, you can see that the real-time chat is working. So I got this up. Let me just send one more message. Uh, so that was the chat app. I think you can see that how easy it is to build a real-time chat app using subscriptions and GraphQL. Going back to the slides now. So there are a couple of good resources to learn GraphQL and get started with GraphQL. Apollo Server is one of the biggest names, and they have really good documentation. There's also a good amount of Flutter ecosystem in GraphQL ecosystem in Flutter. So you can check out that as well. And I think that was it from my side. Thank you all. I just have one thing to say. I mean, two things actually. One is that this code is obviously available. You can check it out, and I actually made it into a repository where you can contribute as well if you have any ideas. And the second thing is I'm working on a new project. You can see this. I recently started it, and I have a very big vision and a very big mission for this project. Since climate change is what we are all facing nowadays throughout the world, I thought of building this project called the Earth Protocol. It is not one specific app or project, but it is a suite of tools which will be open source, and I'm hoping to build a community around it and work with big organizations to sort of help fight this crisis. And I just wanted to show it so that if any of you feel the same mission and want to help, that we can really make some impact. So that's why I mentioned some goals, missions, and what we are trying to do. And I'll be also updating it with roadmaps and everything. I very recently started this, so I have a long-term vision for this. So we'll be developing this over the next 2-3 years, and I hope that I can build a very successful community. So if you're interested, please do come join me. It'll be a really good mission to work on. So yeah, I guess that's it. You can check out my code, or if you want to talk to me, you can text me on Twitter as well. So thank you.
Thank you, Samir. That was actually a very great talk. And by the time I have met Samir, I have been asking him about the Earth Protocol. So if any of you are actually interested, so go and be a part of that. That's actually a very good thing. Yeah, so we'll actually be having a 10-minute break for now. You can go ahead, have your snacks. We have everything there. So yeah, we'll be joining us with our third speaker after 10 minutes. Yeah, please be seated. So we actually have something for Hasnain and Sameer. Like, can you please come here? Hasnain. Yeah, let me just get it. So it's like some goodies for you. It looks like, what is it? I don't know. Please tell me as well, because I'll be able to speak it next time. If you tell me. Like, Rishabh. No, no, it's only there available. I'm not sure that if I should put it or not, then take it.
I was having one problem to open the app, not while connecting, but while requesting the signature transaction. But that was, I guess, that was Metamask problem. When I connect with Trust Wallet, it was open Trust Wallet. Then in the thread, I read that you need to open the browser. It will open the app.
They're like Diwali gifts for us.
Diwali is too far.
Yeah. Have this, guys. Thank you so much. Thank you. Vijay? So we'll be actually having our third speaker now. He's Aditya Thakur, and he's actually a developer advocate at 100ms, and he is also a YouTube creator. He actually has, I think, 6K subscribers, and he'll be talking about Material 3 in Flutter. So yeah. Hi Aditya. How are you?
Hi. Thank you so much for having me. I hope I'm audible.
Yes, you are.
Okay.
So,
Thank you.
all set for your talk?
Yeah, really excited for this.
Okay, then the stage is yours.
Okay, thank you. So, hello everyone. I am Aditya Thakur. Really excited to be here today, and I would have really loved to be there in person and meet you all. But I would be joining online for this session. So, in the recent Google I/O announcements, the Flutter team announced support for Material 3 or also known as Material U. And today we would be talking about that, looking at some of the components that are readily available for you to use inside your own Flutter applications, and generally be looking around the issue around Material 3. So what all we can do with it. Starting off, a little bit about me. I am a Flutter developer. I've been working with Flutter for around 2 years. Right now, I'm working as developer advocate at 100ms. It's a video infrastructure company. And other than that, I have been a speaker at some of the conferences such as Flutter Vikings, the Global Summit. I also have a YouTube channel of my own where I put up videos around Flutter, and also a community of 1,000 plus developers on Discord, where we again talk about Flutter. So around about today's session, starting right off, what it is like, what is material design? I want to talk about that, and then around the components that are available in Flutter for you to use inside your applications. So material design is this adaptable system of guidelines that provide you like a user interface design, best practices around that for you to use. And Material U is this latest update that is more beautiful and personalized. Flutter has announced support for Material 3. It includes all this new color system, typography, which we would be looking at. And generally, you can take advantage of a more adaptable cross-platform design system that would offer you like a dynamic color scheme and some updated visual components. So as of now, Material 3 is available for you to use as an opt-in option. Your theme data, you can toggle Material 3 by typing in use Material 3 and setting this to true. Let's see that in demonstration right now. So I have a Flutter project running on my system. I've created it using the Flutter create command. And also right now, the Flutter version that I'm on is Flutter 3.0.1, which is the lit. I've created a normal Flutter project. It comes with files that are already created for us. And this is the demo application that we are all generally familiar with. Lets you increment the counter on screen by clicking on this floating action button. Now you can use Material 3 by going over to your theme data and typing in Material 3 and setting this. If I restart my app, see our family counter application has been updated to the new designs. There are some directly notice. The first would definitely be the from the app bar goes away, and then you see the action button is a bit updated. So what is all like? What all is new inside this Material 3? A lot of things that are there. There are updates available to the floating action button. So the previous Material design 2 floating actions were a bit round. They're a bit better. Like having worked with designers a bit and fiddled around UI UX, you would see like this is a bit more sleeker and a better design when it comes to the looks. There are also other component updates which we want to look at. The first is the like the upper application bar that you can see. So you come back to your project and go down to where your like app bar is there, and there are two properties for you to fiddle around in this one. So in addition to this new look, the app bar now supports a surface tint color scroll under navigation. Inside this GIF that is accompanying this slide, you can see like when you scroll over, you can modify certain properties. You can modify this surface tint color available, and you can also set a scroll under elevation. By default, there should be a scroll navigation which changes to 3 when you know something is the app bar. And let's just try it out by inside this application of our own. Down to the body, get the default code that is available to me, and instead of this, I'll use the list view builder, so which will take in an item builder. I'll pass in the context and the index, and return a container. So I can give height and width to this container. some height for now and some width to this container, and also add a child text which takes in this index as toString. So I'll say this quickly, and you'll see like a long list appear here. This is just for demonstration purpose. But what you'll notice is when I scroll a bit up, you will see this color change on the app bar, which is the surface tint color. And you can also modify the scroll under navigation. So you can change this coming back to your app bar itself and modify this surface tint color to you. Change it to anything such as colors dot be red. Save this, and now when you'll do it, the color on the app bar changes. So with this, now you can modify both the scroll under navigation, because by default this material 3 wouldn't have elevation that the previous process with the app bar. Now it will be scroll under elevation. So this would change to 3 when there is something being scrolled beneath this app bar. So there is also the new bottom navigation available to use, which you should check out. So inside our same scaffold, what I'll do is, instead of using a bottom navigation bar for the scaffold bottom navigation property, I'll use something called a navigation bar. Now this navigation bar takes in destination. So this destination would be a of destination values where do when you click on the bottom nav. So I'll set that destinations. Destination taken something of navigation destination. Navigation destination which would take in icon. This would be icons that be any icon for this. Just take something like this and the label. Similarly, we could have like multiple options. That we can do. And before I do this, I have to create a current page index. So create a function set page index, which would be used to navigate between the different pages. And I can create, it will take in this initial value and change it to the new value. And then I can do current page. What do I? So yeah, that should do it. Now coming back to navigation bar itself, I'll take these down and change the selected index to this page index, and also on destination selected set index. So this file, and you'll see like a bottom navigation appear here. Since you had changed the surface tint color, only modify the app bar on top. I'll get rid of this, and now it would be more unified theme across. But I can change this to a second value maybe. And you'll see there is this when you click on a new animation that is available with the bottom navigation, it will first highlight the icon for the particular navigation destination, and then it would also show the small animation with it when you switch one bottom item to another. Now there is also one more property that you can modify with this, which is the label behavior. So you can type in label behavior and type in navigation bar destination item. Which will take in something called navigation destination label behavior dot always hide. I'll save this file. Now you'll see like the labels that are associated with these destinations are hidden. You can always set these to always hide, maybe to always show, depending on if you need them. There is also one which is only selected, only show selected. So if I do them, now when you select the bottom bar icon, it will only show for the ones that are selected. So this was the MFL of bottom navigation. There are also updates to the colors and themes that are available. Since Material U is more adaptable, it would change depending on what wallpapers you have on your Androids. But we also want to have like more colors that we can tap into some of these. Material U expands this color space by adding some tertiary colors. The new colors that are included include this tertiary group and container variants for several of the colors. Two colors being deprecated in Material 3 mention are primary variant and secondary variant. So these are all the color to the color scheme. There is the primary container, secondary container, there are on tertiary containers, outline, shadow, and all these colors available. There's a very interesting talk by Mike, which he did on colors and themes, which is more vast and which covers more in length about all the changes being made to color and scheme. Two interesting updates to note here in Flutter 3 are also updates to the card, which would give you access to using these elevators filled and inside your Flutter application. There are also updates made to using an alert box. So if you use a button inside your Material application, like inside your body, let us say you have an elevated button. Inside this can show maybe a dialog box. Show a dialog box using the show dialog box. Could take here, you can build a dialog box passing the context. Have a child. See this file really quickly. So you can see like the buttons have to be updated, and if I click on this, it should show an alert, which is a little more coverage, better in the UI sense. So there are these updates, and there is also the new typography, which is like a typography styles have undergone simplification. So before Material 3, there were 6 headline variations. There were 2 subtitle variations. Material 3, there is more regular and smaller number of variants for each classifications. Namely, you would have this headline small, headline medium, large, and all these options, different options to work with. And adaptability is here, like you will have more adaptable designs. And for this particular one, there is a cookbook by the Flutter team itself made available on the websites that you can follow and learn more about. You can build apps in Flutter. So what's next with this Material 3? There are a few done. Namely, in this particular issue, if you'll go back, the same issue that is there. There are certain features that they are currently working on. There are change to icon button, bottom app bar, draw, and switch that is being worked on. New features are added. Some of the Android features need to be updated, and more importantly, there is this Material 3 iOS adaptation that needs to be done. Within typography itself, you need to support material symbols, and this work ongoing in other repos. So generally, you can with Material 3 right now, you can opt in to add beautiful Flutter application, test it out, try out different things. Let's talk majorly some of the components that have changed, some of the properties, associated properties with them, and also some examples as in the show alert dialog box, and around that how you can get started by just fiddling around with Material 3. Beyond this, if you have any questions or if you want to reach out, you can always do that on like Twitter itself. You can reach out to me on Twitter, join my community, and maybe ask your questions there or here itself in the comments, and I would be happy to answer. So that would be it from my side. Thank you so much.
Hi, Aditya. That was actually a great talk. So, is Material 3 something that just came with Flutter 3.0?
No, it did not come with Material 3. Like it did not come with Flutter 3.0. They have now support for it in like Flutter 3.0. Like Material use there. They have to include migrations for it within the Flutter design itself.
Okay. Okay. Yeah. Thank you. That was Aditya Thakur actually. So, thank you, Aditya. We actually have Vikas as our next speaker, if I'm right. Yeah. Hi, Vikas.
Yeah, hi Nitish.
So Vikas here actually works with us at GeekyAnts only. So he'll be talking about performance and optimizations in Flutter. Am I correct?
Yeah, that's correct. Actually, I'm kind of feeling nervous after those amazing talks.
No, no, you'll do great. We know you. Yeah. So yeah, the stage is yours. You can just go present.
Okay, sure. Thanks, Nitish. So, hi everyone. Myself Vikas. I work for GeekyAnts, and I'm working from GeekyAnts for now about 8 months now, and I'm going to talk about performance and optimization in Flutter, specific to Flutter. This is not a topic specific to Flutter, but in this talk, we are just sticking to Flutter. That's all. Now let's jump right into it. Let's cover the topics that we are going to cover in this talk. First of all, we are going to talk about methods and versus widgets. After that, we are going to talk about async await, and after that, concurrency in Dart, and then isolates, and then we will explore some dev tools along with this. So let's talk about methods and widgets. Avoid rebuilding widgets. What does it mean? So I have stated a warning here that don't use long build methods. So why don't we use long build methods? What's the reason? First of all, readability. It's hard to read long code, long files and stuff like that. Second of all, performance, and we will get into that in few slides. And third one is my personal opinion, it doesn't look good. So what are the solutions? If you don't want to use long build methods, then what are the solutions? Most of the developers would say that break down your code into functions. So okay, let's do that. Functions or methods. Ignore this cross sign for now. We will talk about that. And functions and methods. So what we have done here, for example, we have this build method. Here is the build, and we have a very heavy widget. Heavy widget means a long widget, and that heavy widget is combined of 3 smaller widgets. So it looks good, it works, and you're good. This is a good way to segregate your code until and unless you are not changing the state. So what happens when we change the state in a Flutter app? Let's say that our widget 3 has a small like icon or favorite icon, you can say that, and it changes color on the tab. So what would happen? We will call set state. That's correct. To change the state, we will tell the Flutter that the icon has changed the color. Now you have to change the state of that icon. So what does this set states do? It goes up the widget tree and finds the nearest build method, the first build method that it gets, and for now, which is this one, and it triggers the rebuild. So what happens when it triggers the rebuild? It rebuilds the heavy widget, and heavy widget along with the heavy widget, we got widget 1, widget 2, and widget 3 all gets rebuilds, and that's an issue. Suppose we have a very complex screen. We have post, we have comments, we have app bar, we have bottom navigation bars, and we are only changing a color of small icon in that screen. Why are we paying all the performance of building these widgets? So that's not a good option. So what's good? Change them into widgets. That's all. It has all the same structure. We are here all we are again calling the heavy widget here, but now it's not a method, it's a widget. That means it's its own class, and in that heavy widget we are calling all those 3 widgets, and they are also separate widgets. So what happens when we call the set state now in widget 3? Let's say we call set state for widget 3. Now it will go up the widget tree and finds the nearest build method. And we have that in widget. So it will only rebuild the widget 3. And that's optimized. That's good. That's good. We have done that. But it's now we have created a Flutter app. We have talked about widgets, we have worked with widgets, but an app is only not only consists of widgets and the UI components. We have to fetch data, we have to make some method calls, we have to read files, we have to write files, and thus that brings to the next topic, async await. So what is asynchronous programming? Let's talk about asynchronous programming first. And asynchronous programming means any operation in our app that is taking time to finish. For suppose like we are fetching data from the server, writing to our database, reading a file, we are processing images and stuff like that. If it's taking time, then it is asynchronous. So what's the approach? How to make an asynchronous call? How to tell Dart that we are going to take some time to perform this action. You have to work accordingly. So there are multiple approaches. The first one is dot then. Now here we have our crazy complex asynchronous function. What it does, it takes 2 arguments, and after 2 seconds it's kept the sum. So pretty complex, right? So now how to use that? So for to call this function, I have called add, and since it is a future, I can nest dot then to it. And dot then is nothing, just like a callback function. It gets populated, it returns the value when the future or the promise gets resolved, and we can use that here any way we want. So that's good. This is good. It looks good. It feels good, and everything is fine here. So what's the issue? We haven't talked about async await yet. So what's wrong with using .NET? The problem starts happening when we try to call multiple asynchronous functions one by one. So now we are chaining, we are calling add, and we have chained dot then to it, and using the value that is returned by first call of to add to call another asynchronous function. That could be any function, but for now, for the time being, we have used add again. So I'm using someone to call add again, and then I have chained another dot then to this, and using that function to and using that function return value to call add again. And for now, we have changed 3 asynchronous calls in a callback one by one. Now this seems pretty ugly. For me, it seems ugly. It doesn't look good. It's hard to read, and we haven't talked about error handling yet. So let's talk about it. What about error handling in .NET? So there are two ways to do that. We can chain .catch error method to every dot then call we have make, or we can return a future from one of the dot then and then use only one catch error to catch all the errors on the above dot thens. So this is the pretty basic method of handling errors used when we are using dot then. So, and this is also known as callback help for JavaScript developers. So what we can do now, there comes async await to the rescue. Now using await, we are telling Dart that you have to stop on this line unless you get the value, and after that you can execute the rest of the below code. So first in the line someone, I have tell Dart to await for the add function to execute, and after the value is returned, then only we can go to sum2, and then we can use the value in sum2 and respectively for sum3. And I have used a try catch to catch all the errors for all the asynchronous functions that I have called. So you can see that how async await changed from this callback held to this heaven. Now there are some few more benefits to async await regarding the scopes of the values. Here I have access when I am calling the function for sum3. I have access to the values of sum1, sum2, both. But while I was calling dot then, when I'm calling the add function for sum3, I don't have access to the value of sum1. To make it accessible, I have to define a global variable, and after resolving this, I have to assign that value to this, and that's a lot of work. So that's not good. Use async await instead of dot then. Now with this, we have covered async await. Now let's talk about concurrency and Dart. What is concurrency? First of all, concurrency means that we have to work on multiple computations simultaneously. Means like suppose I have given Dart a task that to read a file, and by using that file I have to change the UI or something like that. So I don't want Dart to stop for reading that file only, and using that while it's reading the file, I don't want Dart to stop all the processes that it was working on previously. So that's bad. That's where concurrency comes in. Concurrency says that we can work on different processes at the same time. So Dart is a single threaded language. We can't do that on a single thread. We have to tell Dart that this is an asynchronous function. You have to run on a different non-Dart VM or the OS on the native level. So For now, we have, that's how the thread of Dart works. We have an event queue. Event queue means a queue of the executions, the computations that we have to perform. We are injecting to the Dart thread and stuff like that. And event loop is responsible to execute all those computations. For now, the event loop will trigger the paint frame. And what happens when it comes to tap event? Let's say that tap event is a some asynchronous function. Synchronous functions like a function that computes immediately, but for some reasons, like we are reading an extremely large file, and there is a method in Dart that read string as byte sync. So we have tell Dart that this is a synchronous function and we are reading a large file, then it's going to take time. We know that. And same goes for parsing a large JSON. For say that we have an extremely large JSON, let's say of 1 MB. It is a extremely large JSON and we are trying to parse that. That is a synchronous function. Dart doesn't know that it has to wait for it. It has to delegate to the VM, different non-Dart VM, or it has to do it on the native level. So what we can do there, for loading an image, we can use read as file string, and we can use async await to tell Dart that this is going to take time. Please don't block the code and do all the other stuff that you were working on. So what happens when the user taps on the event? This blocks the event loop and thus causing the jitter slash jank in the UI. Means suppose we are fetching a data from the network and we have extremely large JSON in the response and we are showing a loading indicator. So that loading indicator will get paused for a little bit of time, and that is called jam. That is causing because of the parsing of large JSON. So what's the solution here? The solution is simple. Dart is a single threaded language, so delegate that work to other thread. And that brings us to our next topic, isolates. So as I told you that this is a synchronous function, this is going to take time. Dart is a single threaded language. It can't handle all the synchronous functions on same thread. So we try to offload this heavy computation to a different isolate. That's simple. If one worker is not able to perform all the tasks, hire a new employee, hire a new worker. That's easy. So how do we do that? There are two methods to do that. First of all is compute. Compute, first of all, let's talk about a little bit of isolates. Isolates, as the name suggests, they are completely isolated from the Dart main thread. There is no way to share memory between multiple isolates or the main thread or a single isolate. There is a way to send messages, and we are going to talk about that in the next slides. And there is a method called compute. Compute doesn't share any kind of messages. It just takes a function to execute. It takes a parameter if we want to provide it a parameter or so, and it returns the value. So what does compute doing here? We told Dart that we are using a compute function. We have used await here. We have used async here. We have told Dart that this function is going to take time. So, and we have given it a very complex function, very complex function of providing me a sum with the number of iterations that I provide. That's complex. So what does compute take? Compute takes an function to execute. It takes heavy computations. It takes a parameter if I want to assign it a parameter. It executes the function and it returns the value. Simple. Behind the scenes, compute handles everything of creating a new isolate, destroying the isolate after the computation is over, and stuff like that. What if we want more control over them? What if we want to send messages? What if uh, we want to control when an isolate gets destroyed? So for that we have isolate.spawn. So what are we doing here? We have a function called isolate spawn. It's gonna return us JSON data after it's getting parsed and stuff like that. And Again, we have told Dart that this function is going to take time, and we have used async and await here. So Dart knows that it doesn't have to block all the execution of other repainting events or any events. So what does isolate.spawn do? Isolate spawn, this is a port. First of all, we define a port, receive port, and using this port, we are gonna send messages and communicate between the isolate. So let's call that method await. We are going to await for the method isolate.spawn, and isolate.spawn as compute. It also takes a function to execute, and it takes a port. The port dot send port means send port is an extension of receive port, an argument, and using that port we can send messages from one isolate to the main thread by writing port dot send and the message. And here we can listen on that port dot listen, and we can listen to those messages and perform certain actions using that. So read and pass JSON is doing what it's doing. It's reading a file, and it's reading a file which is going to return a very large uh, data, and after that we are in decoding that data and returning that data to the isolate spawn. So isolate.exit, what does it doing? It destroying the isolate and returning the JSON data at the same time. So here we have complete control of when we are going to create an isolate, when we are going to destroy an isolate. So we have talked about async await, methods versus widgets. We have talked about concurrency. We have talked about isolates. So the thing comes that when to use them. How do we know that this portion of the app is taking is taking too much time? This portion is creating the jank. This is the issue where we have to look that this API is sending a very large JSON as a response. So for that, let's get to our next topic, DevTools. Flutter has an extremely good collection of DevTools. We can say that it is one of the best, actually. We can inspect the UI layout. We can we can see the change in frame rates. We can do the profiling. We can see the network calls made by the API. We can see the how much memory it's taking. We can analyze the code. We can check what size the app, and a lot and many more. So we will talk about some of that stuff. So first one is Flutter Inspector. I think every one of the Flutter developer has worked with Flutter Inspector. So how does it work? If no one has worked with before, I don't know what they are doing. We have to enable this. Select widget mode. After enabling this, we get a screen like this that it shows an overlay that we can select any kind of any widgets in the UI. And while after I tap on the UI, it shows me the layout that how it is rendered, and the best part of it all, it takes me to the code where that UI component has been written. So while working with a large app, it is one of the most used tool to go to the specific component that you have to work on, and that's the power of Flutter Inspector. And after that, we have performance overlay. Here we can figure out what part of the UI is causing the jank, the jitter, and stuff like that. To do that, you can always enable performance overlay, and with this, you will get an overlay in your app itself that how it is going to perform. And when you get this overlay, you can scroll through your app, you can perform actions, and that will give you a graph of the frame rates that you are getting on that specific portion. And by that you will be able to determine that which part of the UI is causing the problem or the jitter or the jam. The next and my favorite is the network tab. Here you can see what API calls your app have made. You can see the response, you can see the data, you can see the headers that you have thrown, you can see whether check what is the size of the JSON that you cut, and many more. So that's all. Thank you guys. Thanks. And if you have any doubts, you can comment on the chat. I will look into that.
Hi Vikas, everyone here was just clapping
Hi.
for you.
Yeah, thanks. Thanks everyone.
So actually that was a very great talk, and I also feel that creating apps in Flutter is comparatively easier than optimizing it. So thank you for actually guiding us on that. Yeah, so one more thing, I think that we also have Aditya over here. So we basically had a ritual where we would like for all of our online meetups, where we would actually have all of our speakers and we basically take a screenshot of it. So Rishabh, I will go to you. Yeah. So we are good. So thank you. Thank you for joining. Thank you everyone. Thank you who have joined us over here. Also, like we actually keep on doing these meetups every now and then. So if you want to like know more about it or get any updates regarding this, then you can actually follow us on all of our social profiles. We are there on YouTube, Twitter, LinkedIn, Instagram as well. So you can just go us follow there, and we'll be posting any updates that we have. And regarding any of these this particular Flutter meetup, you can actually tweet for this with hashtag FlutterBLR. Yeah, that's all. Thank you everyone for joining. Thank you.
Yeah. Thanks, Satish.
Thank you so much.
Thank you. Thank you, Vikas. Thank you.
Thanks.
Sorry.
Bye.